in the past 2 days, and for A and B we talk about the ratios in right angle triangle. We have sine, cos, and tangent, and also we know if given us a particular ratio how we can work out the angles from the calculator. So today we want to apply this into like real life situations. The first thing we'll talk about is the angle of elevation and depression, and I believe in year 9 we briefly talk about that as well. So this is application in 2-dimension shape. So the angle of elevation or depression of a point from Q from another point P is given by the angle made by the line PQ with the horizontal. So well, it's a, don't worry about this. What you all need to know is angle of elevation and angle of depression must be the line made with the horizontal, not the vertical. Last year, well, maybe 2 years ago, when I teach year 9, like we talk about angle of elevation and depression. When there's an application question, students very easily take that like line from P to Q with the horizontal, treat that as an angle of depression. That's wrong, okay? So all you need to remember is that must be the angle made with the horizontal, not the vertical. So what's angle of elevation and angle of depression? So if we have 2 points, okay, so let's say point A and B. Okay, A needs to look up to see B. So this will be an angle of elevation because we're looking up. Okay, so this is the angle of elevation. So we connect this line. And then we make the angle made with horizontal. Okay, so we have our horizontal here. This angle theta we'll call the angle of elevation. So from A, I'm trying to look at B. Like my eye goes through from here to there. Okay, it seems like there's a straight line here. And then this line will make angle with the horizontal. So that we'll call the angle of elevation. So same situation, A is here, B is here, but B trying to look onto A. So B will look down, okay, look downwards. So B will look through this way. So this is called angle of depression. I'm looking down there. So still the same line and still made angle with the horizontal. Okay, still make angle with horizontal. So this angle, let's say alpha, is the angle of depression from B to A. But what you can realize is these two lines are parallel lines. Okay, they're all horizontal lines. Okay, horizontal and horizontal, they are parallel to each other. This is an alternate angle. Okay, alpha and theta, they are alternate angles. So therefore, alpha and theta should be the same. Okay, angle of elevation and angle of depression from the same 2 points will be the same. Okay, look, it must be A squared, B squared, not changing. And then A look to B and B look to A. Angle of elevation and depression should be the same. Okay, so that's explaining what's angle of elevation and depression. Now let's have a look at the examples. Well, let's do example 2 first. I want to leave example 1 for you to think about. Okay, let's look at 2. Example 2 says 2 vertical buildings 57 meters apart, and one is 15.8 meters and the other one is 237 meters high. So we have 2 buildings and we have 15 meters apart. So let's sketch this first. Okay, we have okay, it's vertical. Okay, building is vertical. So I can use just a line to represent that's one building. That's the 158 meter tall building. Okay, another building is quite tall. Okay, so that's another straight line, and this building gives me 237 meters. 837 meters. Okay, so find the angle of elevation from the top of the shorter building. Okay, say person A stand here. Okay, the top of the shorter building to the top of the taller building. Okay, this is the taller building. Okay, from A to B. Okay, A look to B will have this straight line. Okay. Okay, A look to B will have this straight line. Okay, this line needs to make angle with the horizontal. Okay, not with the vertical, not this angle. Okay, not this angle. This is the common error. Students really easy to treat this angle as angle of depression and say therefore it's the angle of elevation, but it's actually wrong. Okay, it needs to make the angle with the horizontal. So I will add a horizontal line here. Okay, which is parallel to this one. Okay, which is parallel to this one. So this angle theta we'll call the angle of elevation. Okay, not this angle. Okay, this angle is nothing. This angle is nothing. So theta is the angle of elevation. So also the building is 57 meters apart. Okay, can you tell me, let's say this point is C. Obviously, we have a right angle triangle here, like ABC. Okay, we have a right angle triangle here, ABC. Can you tell me what's the length of AC, please? 57. And what's the length of BC? How do you work on that? Take away 158, and we have 79 meters. Okay, 79 meters. So what kind of ratio you can tell me? Like what trig ratio you can give me? 10? 10 what? Theta? 79 and over 57. Okay, good. So we have this ratio here. Okay, we have this ratio here. If we have this ratio, we can work out the theta. Okay, we can work out the theta. So theta should equals to tan inverse 79 over 57. Okay, 79 over 57. So if we can go to the calculator, well, my calculator is the wrong mode. Degree mode. Okay, go back to the current. Better open a new one for you. So we want tan inverse 79 over 57. Press enter. Well, that's the exact values. So I don't want exact. Control enter. That will give me the approximation value. So it's 54.19. Okay, 54.19. 19 degrees. Okay, the unit is degree. So 54.19 degree. Okay, that's one of the example how trig ratios can be used in angle of elevation and depression. All we need to do is still set up right angle triangles. Well, you can find, you need to, well, if you can't see any, we need to create one. Okay, we need to create one. So we will create A, B, C, and then set up the ratios. Okay. All right with this one? Okay, let's move on to the next one. Okay, let's move on to the next one. Okay, Peter observes a plane flying directly overhead at a height of 820 meters. Let's say Peter is on the ground. Okay, we have Peter here. Let's ignore the height of Peter, okay, because we're trying to observe something really high, like 1.5, 1.6 meters is not that important, so 2 meters is not that important. So we ignore the height of Peter this time. So we have point P here, and then Peter find the plane is about here. We use A to present the plane, like Peter is there and the airplane is 820 meters above. Okay, 820 meters above overhead, okay, at a height of 820. Okay, 20 seconds later, the angle of elevation of the plane from Peter is 32 degrees. Assume the plane flies horizontally. Okay, the plane not going to go down or go up, so fly in that direction. So fly to somewhere. That's like, let's say that's 820, like after 20 seconds. Okay, what happens at that time? The angle of elevation from Peter to the plane from Peter to the plane, and Peter looks to that way, give you an angle of 32 degrees. Okay, 32 degrees. Which angle is 32 degrees? Let's say angle 1, 2, 3. Which angle is 32? 1 is 32 degrees, or 3 is 32 degrees as well. Okay, because the horizontal line alternate angles, it can be 32 as well. So I'll say this angle is 32 degrees. That's the angle of elevation made with horizontal, not vertical. So what's the size of this angle then? What's this angle? 58, good. 58 degrees. Well, this one is 32 as well, as I said. Okay, this must be right angle triangle, because like look directly vertical up and then move to the horizontal, so that create a right angle triangle for you. Okay, question is, how far to the nearest meter did the plane fly in 20 seconds? Let's say this x is the distance. Okay, that's how far the plane fly, right? From 8 to 820 in 20 seconds. So that's how far the plane flies. Okay, what you can do to find that x? Or what trig ratios you should give? Sine, cos, tan, what you should give? 10? Okay, 10 of 58 degrees equals to x, yeah, thank you, x over 820. Okay, so I have set up a trig ratios involve the variable I need into the equation. Okay, into the equation. So x equals to 820 times tan 58 degrees. Okay, x equals to 820 times tan 58 degrees, because tan 58 is a number. Times tan 58. Okay, 20 times tan 58. Control enter to give me approximation values. So that's 1312. Okay, 1312 meters. Okay, because 820 meters, and that will be meters as well. So 20 seconds, fly 1312 meters. Okay, what's the plane's speed? Well, let's ignore the unit first. What's the speed? What you should do? Yeah, distance over time. So speed equals to 1312 over 20. That's meter, well, unit is meters per second, right? The meters divided by the second is meters per second. How I can convert that into kilometers per hour? Well, if you can't remember the direct ratio I should convert, let's think about it in this way. Well, I need distance divided by time, right? Distance divided by time. So my distance is in meters, unit is meters, and then the time is in seconds. How about we convert that into kilometers per hour directly? Okay, so 1,312 meters equals to how many kilometers? Yeah, 1.312 kilometers. Okay, how 20 seconds can become how many hours? Well, in each hour, how many seconds are there? Yeah, 60 times 60. What is it? 3,600. Okay, 3,600. If I want to convert seconds back to hours, what do we need to do? Well, it can't be 180 hours. So we need 20 divided by 3,600, right? Each hour you have 3,600 seconds. Now 20 seconds divided by 3,600 will give you a unit of hour, right? Well, each second is 1/3,600 hour. Okay, 2 seconds is 2/3,600. So 20 seconds is 20/3,600. So that can convert 20 seconds into how many hours? Okay, it's a very small value, but it's alright because that's what we get. So that's a very small fraction. So it's 1/180. Okay, so this will equals to, well, I don't know what that equals to. I put that into the cats. 1.312. 1.312 over, okay, a fraction 20/3600. Okay, that's the fraction I will have. I make it enter another time. Okay, looks better. Okay, so to the nearest kilometer, so it's 236 kilometers per hour. Okay, 236 kilometers per hour. Okay, one more thing. For the unit kilometer per hour, convert to meters per second, or from meters per second convert to kilometers per hour. This one I need to times by 3.6, and the other one I need to divide by 3.6. Okay, because I want to convert meters per second to kilometers per hour, I need to times by 3.6. If you remember the ratio, that's fine as well. Okay, you don't need to go through what I'm doing over there. You can just times simply by this number by 3.6. And or you want to convert this back to meters per second, you divide that number by 3.6. Another question is, 1 meter per second and 1 kilometers per hour, are they the same speed? No. Okay, which one is faster? 1 meter per second compared to 1 kilometers per hour. Which one is faster? How do you decide? Like, you need to convert at least into the same thing and then compare. Which one is faster? Second? Yes? 16 meters per second, 2 kilometers per hour, we times 3.6. So this actually will give you 3.6 kilometers per hour. It's a much faster speed. Okay, it's a much faster speed for 1 meter per second. Or you can think in this way. Every second I can run for 1 meter. Yeah, every second I can run for 1 meter. How many hours are there in, how many seconds are there in 1 hour? 3,600, right? So every second I can run for 1 meter. So in 1 hour, I can run 3,600 meters, which is 3.6 kilometers, and that's 3.6 kilometers per hour. Okay, so you can, if you can't remember the conversion, you can remember in this way as well, the reasoning part. Like 1 meter per second. So how many seconds are there in 1 hour? So that's how many meters I can run. Then I can convert it into kilometers, which is 3.6. Meters to kilometers needs to be times by 3.6, and then the kilometer back to meter per second needs to divide by 3.6. So if you want to convert this one to meters per second, I need to divide 1 divided by 3.6, which will give you point something, so which is less than that one. So this is a faster speed, and this is a faster speed. It's very confusing, but like it's very important. Okay, those two units that like we like to test that a lot. So meters per second and kilometers per hour. Also in the VC exam, you might have questions like that as well. Okay, well, example 1 4 pretty much similar to what we do here. I want you to try example 1 by yourself. It's a little bit complex for example 1. So you have about 20 minutes left. I want you to complete example 1 and then you can do your homework. Okay? So try example 1 and then do homework. I'll show you the answer later after like 10 minutes. I'll draw the diagram for you here. So try example 1 by yourself. After you finish, you can do the homework.